All right, hello. We are looking today at 8 OneNotes, finding the greatest common factor and then factoring it. The targets are I can find the GCF of a monomial and I can factor a GCF out of an expression. So let's review and talk about what factors are. If I ask you to find the factors of 28, I need to find two numbers that multiply to get to 28, two integers. So I can think about 1 times 28, 2 times, if I'm not sure, I can go to my handy calculator and I can do 28 divided by 2 and I'd get 14. 3 times anything. If I do 28 divided by 3, I get 9.33 repeating, so 3 is not a factor of 28. Factors need to evenly go into number 28. 4, we got 28. We can do 28 divided by 4 if we're not sure. We get 7. I can test out 5. It doesn't work. 6 doesn't work. And now I'm ready to test 7. Well, I already have it listed. So these are all of the factors of 28. I wrote them as factor pairs, which we will be doing, but some of you may have seen factors written in a set of parentheses in order from least to greatest. Okay? All right, so now let's talk about prime factorization. Prime numbers are any number where the only factors are 1 and itself. So for instance, the number 3 is a prime number. Why? Because the only factors of 3 are 1 times 3. 5 is also a prime number. 1 times 5 is the only way to get 5. 2 is actually the only even prime number. 1 times 2. The other numbers that have more factors than 1 in itself are called composite. We've heard that word, I'm sure, in the past, but just to revisit what it means. When we talk about prime factorization, we talk about when all of the factors of a number are divisible by 1. So at the very end of what you'll see, a prime factorization tree, all of the numbers should be prime numbers. So let's take a look at 24. Let's think of any two factors we can split 24 into. Any two numbers. So as long as it's not 1 times 24, we can go, let's say 4 times 6. Those are both composite numbers because I can break 4 into 2 times 2. Well, these are indeed prime numbers, so I'm going to circle them. I can break 6 into 2 times 3. These are also prime numbers. So do you see at the very bottom of my tree, I only have prime numbers. All right, so now how I can write this prime factorization, I can write it two ways. I can write 2 times 2 times 2 times 3. If I plug that sequence of numbers in the calculator, I should get 24. I can also write it as 2 to the third power times 3. Either of those work. All right, I want you to go ahead and give number 2 a shot. Break up 60 into prime numbers. All right, let's see, 2 and 30, maybe you chose those two factor pairs. 2 and 15, maybe those two factor pairs. And then we have 3 and 5. So really we should have 2 times 2 times 3 times 5, or 2 to the third times 5 times 3 times 5. Or you could do it times 5 times 3. Remember, multiplication is commutative. All right, that's prime factorization. Let's find the greatest common factors of the group of terms. So we have 12 and 27. We need to find the factors of 12 and the factors of 27. I'm going to work in factor pairs. I always start off with 1 times 12. Again, if I'm not sure, I can go to my handy calculator. My next factor pair should be 2 times 6, and then 3 times 4. My next number I should try is 4, and I already have it listed, which means I have all of my factor pairs. 27, 1 times 27. 2 doesn't go into 27. 3, we got 3 times 9. And then we would keep going, 4, 5, 6, 7, 8, 9, we already have. So there are all of the factors of 12 and 27. Now I'm looking for the biggest one, the greatest one. I'll have pairs of numbers that have lots of common factors, but I want the biggest one. So if I look over here, I see a number 3 and I also see a number 3 there. My GCF is indeed 3. All right, go ahead, try number 4. List all the factors of 24 and of 60, and then come up with your GCF. Hopefully you came up with a GCF of 12. If you didn't, go back and make sure you have all of the factor pairs. All right, now that's just finding the greatest common factor between two numbers. Now we're going to focus on finding the greatest common factor between two monomials. All right, let's take a look here. I have 3x cubed and 9x to the 5th power. I'm going to separate 3 and x cubed and 9 and x to the 5th power. Let's find the common let's find the factors of 3. 1 times 3. That's it, because it's prime. The factors of x cubed, think about expanded form. The only way I can get x cubed is if I multiply x times x times x. Now 9. 1 times 9, and then 3 times 3. X to the 5th, the only way I can get x to the 5th is if I multiply x times x times x times x times x 5 times. All right. Now what I need to do is I need to analyze and find the GCF of 3 and 9. So my greatest common factor is going to be 3. But now I need to take a look at x cubed and x to the 5th. I think about what's the maximum number of x's I can take out of both. So I have 3 here and I have 5 there. Well, I can take these 3 out of x cubed, which means I can only take the 3 x's out of x to the 5th. Here's a hint. You should have the same exact number and number of variables circled on both sides. My GCF between 3x cubed and 9x to the 5th is 3x cubed. Okay, so that is identifying a GCF of two monomials. Let's go ahead and practice with number 6. Okay, it might look a little intimidating at first, but really we're just going to break up the 7, the a, and the b cubed, and the 21, the a squared, and the b to the 5th. Let's go ahead and list our factors. We should have 1 times 7. The only way to get a, really, that's a to the 1st, so we got 1a. And then we have b times b times b. Go ahead, try 21, a squared, and b to the 5th. List all the factors. All right, we should have 1 times 21 and 3 times 7, a times a, and b times b times b times b times b. Now what I look for is what do I have in common? All right, we should have the 7 in common. I can look at my a's. The maximum number of a's I can take out of both terms. There's only 1. And then the maximum number of b's, b cubed, b cubed. So my GCF happens to be 7ab cubed. All right, that is the GCF of the following, or that's the GCF of those two monomials. Let's do number 7 together. We have 3 monomials, and that's okay. We're going to separate them, finding the factors of 4, the factors of n cubed, factors of 16 n squared, and then 8 and n. All right, go ahead, hit pause, take a minute or so, list all the factors, and see if you can come up with the GCF. All right, your GCF should be 4n. And how you got that? 1 times 4, 2 times 2. Then we have n cubed, then 16, we got 1 times 16, 2 times 8, 4 times 4. And then 1 times 8, 2 times 4. And I can circle it. It has to be in all 3. 4s are in all 3. And then we got 1n here. That means I can only take 1 from each of them. All right, this is the first half of the lesson. So thanks for watching. We'll finish up in the next video.